So it's time for our roundtable discussion. So let's welcome our panelists, Mrs. Shi Huiling from TankeBlue, and Dr. Christian Newman from Heraeus, and Dr. Wang Lizheng from the 48 Research Institute of CETC. And welcome the moderator, Mrs. Qiu Qi. 欢迎我们的3位讨论嘉宾，一位是史慧明施总，来自北京天科合达；一位是我们的 Christian Newman 博士，来自赫利士；还有就是我们的王立正博士，来自中电48所；还有欢迎我们的主持人邱奇邱总。
Good morning, everyone. My name is Vicky from Global Power Tech. So before we start the roundtable, I have a question for Christine. I just heard the news that Heraeus just invest European SiC Blue company. So what is the main goal for this investment? Can you share your thoughts about that?
Is this on? Well, okay. Okay. So we just heard in the talk of GPT CEO right now that there's this 0 to 1 and 1 to 99 aspect, and while I would say the silicon industry is a very mature one where you can actually actively scale from 1 to 99, in silicon carbide there are a lot of unsolved basic research topics, and this starts from the unresolved plethora of physical point defects, elongated defects, two-dimensional defects that can appear in the silicon carbide. You also have, again, we just talk about crystal defects without talking about foreign doping defects or whatever. And this leads to degradation mechanisms. For instance, bipolar degradation in MOSFETs today is the single most source of, I would say, failure in the silicon carbide, and that's why all the players, especially the automotive industry, they just account in that this equipment will fail and we need more material. Actually this starts at the very beginning of the production chain of silicon carbide. Even before you actually make the boules and the wafers, it starts with the feedstock. Right now, the feedstock for the PVT growth is not reliable, and it's not always the same. And you need something which is 100% highest purity, consistent quality as a feedstock to start the PVT process. We learned that other processes, and also a very good talk from Tanke, we learned from that PVT will most likely be the method of choice to scale this in the near future, and our investment into a company who actually now actually brings up a solution to this should be one of the innovative disruptive steps where we think that this might be a very smart move and which could bring the whole industry ahead.
Oh, that's a really meaningful investment, and hopefully you will have a very breakthrough on the silicon carbide material part. Okay, since we have a lot of questions from before us talking about transfer from the 6-inch to 8-inch. So how to determine the industrialization schedule from 6-inch to 8-inch? I mean the 8-inch mass production, not just for the demos. And what is the difficulties facing when we have this transfer to make mass production? Maybe we start from the silicon carbide material part. Huiling.
Can I speak in Chinese?
Sure.
There's no way.
问题是说这个8寸产业化的时间轴是吧？量产这个就是国内国外可能情况不太一样，国外的器件厂基本上都已经在布局8寸线，然后现在也在跟我们国内的车企业都在谈8寸 们得到的消息基本上都是2025年开始就要开始8寸的正式量产。然后国内的器件厂的话，可能8寸上要稍微慢一点点。我们现在看到的这个国内有8寸布局的，包括咱们泰科，然后绍兴，然后这个其他的那个新远能吧，反正号称有布局，但是还没有实际的这个。其他的好像目前都还集中在6寸。我个人感觉吧，国内的器件厂可能6寸上可能还会再发展一段时间，8寸的这个切换时间会越来越快。你的第二个问题是什么？难点首先是这个衬底。说实话，这个8寸你看这个 WSB 的最早是15年就公布了8寸的这个研发的成功，到现在才去年才正式实现量产，而且也不是很顺利。它的8寸这个器件厂投产实际上很不顺利，直接就导致它的8寸的晶圆厂投产受到了影响。所以说这个8寸衬底的这个生产肯定是一个难点但是好在就是这个8寸的技术进步很快，尤其是中国企业的这个加入到8寸这个衬底的这个竞争当中的话，会很大的加速这个8寸衬底的这个产业化的进步。所以衬底端肯定是有难度的。然后器件端的话，这个我就不说了，这个周总可以分享一下您的见解。
我觉得刚才讲的683的进度，我跟石总的判断也是一样的，就是说现在目前可能据我所知因为我们中央厂商，就是说从外延端就是已经有很多客户已经在布局了，就是说但是可能瓶颈还是我们的衬底去跟不上。第二个就是可能在器件端的话，可能整个的设备成熟还不够，因为就是从6寸我刚才讲了，从6寸的话它是一个比较大的质的倍源，就是说它对那个颗粒度、对粘物这些都有比较高的要求，可能就是包括国内国外，它其实可能还没有，就是说没有完全，我不知道那个 Panelists 它也是宣称2025年所以说其实可能还有一些东西需要磨合，包括良率包括像刚才大家说的偏厚，是吧？我们目前6寸都是350，但是8寸的现在很多还是500，它是一个怎么样兼容性的问题，就是说可能我觉得有个过程，但是很可能因为就像只要我们衬底比较快突破，整个还是会比较快，因为国内原来在整个硅基的8英寸的这个产线，包括装备领域还是有很多积累所以我想只要这个环节，包括后面的终端的应用打通的话，应该还是会很快大家预判的话，可能到2028年，可能就基本上会就是当然就是因为从8英产就可能会实现一个碳汇跟一个硅的一个评价这是我们还有很多专业的一个初步的判断
It would be good to get a short summary of what my other two.
They are talking about the bottleneck if the steel silicon carbide substrate, when it transfers to 6-inch to 8-inch. So substrate still the bottlenecks. Equipment doesn't matter because the 8-inch equipment is already there, quite relatively mature, for the 8-inch equipment.
Yeah, I mean, the equipment definitely will not be the problem because a lot of the learnings that we already had from 12-inch or even in the silicon industry ended at 12-inch despite they wanted to also go to 80. And we prepared for this about 15 years ago and had all our materials in the part, but handling issues and everything stopped the activity at 12. So there is an educated guess that for silicon carbide it might even end up at 8. So you never know. But in terms of wafer growth, wool growth, it's absolutely senseless to make bigger wafers as long as you cannot put down the defect densities in these materials, because then you end up having a big substrate, but you cannot use the outer rim, because, for instance, the basal plane dislocation density is so high that you will not get out a singly good device. increasing the defect density, or let's say increase the defect density, increase the quality, is of utmost importance, and I think that's also what Tanke is doing all the time.
Okay, thank you.
I would like to add some information about the 8-inch substrate. You talk about when you talk about the defect. When we talk about the 8-inch, definitely we will keep the same quality or even better quality compared with 6-inch. So that will not be a problem.
That's it.
So I think we are doing quite good on the 6-inch. The company like TankeBlue and SiC, they have already sold substrate to the company like Shi Huiling and Stanley, right? So what about the 8-inch? We still have so much gap to chase compared with the international company. Further between the big gap between the local company and the international company when they're doing the 8-inch. Still have a big gap for that.
是有touch到吗？或者是说与时准度的厂商跟这个国际厂商的差距还是很大的，还是说相对很下行？我觉得没差距了，已经。他跟我聊的时候，是吧？因为我是觉得国内厂商很多厂商有差距，这方面的。
So why we care about transfer from 6-inch to 8-inch? Because one of the ways to try to reduce the cost, so we can enter more market to replace the silicon device. So that one of the important reasons why we want to transfer from 6-inch to 8-inch. So if there are other ways we can reduce the cost. Besides transfer to 8-inch, is there other way we can reduce the cost, like from the material to the equipment? Is there other ways?
Okay, I'll answer first. Let's do it in Chinese. 我刚才的报告里头也专门有一页分享了关于这个成本这一块的。这个就是因为我们谈这个 reduce cost 的话，就是要从这个至少从晶圆制造这个环节来讲嘛。也就是除了像这个，所以除了降低这个上游的这个材料，包括外延的成本的话，在基建端的话，应该有一些降成本的空间。单纯的从材料端来讲的话，我们降成本的话，刚刚也提到了这个涨后，然后这个晶体切割的工艺的这个新的工艺的引入，包括这个抛光工艺的新的工艺的引入，这些都可能降低成本。然后从这个，其实还有一块就是这个设备和原材料这块这个如果国产化的这个比例更多的话，有可能还会再进一步的降低这个成本。大概是这些方式。
刚才当然，现在目前就是我感觉就是可能，但很多的关于碳硅就是怎么样降低成本。其实我觉得我要提醒大家的就是说，目前其实我们的碳硅的应用它跟硅的应用它并不是简单的拼成本，就是怎么样把我们碳硅的优势能够发挥出来，这个是非常关键的。就第一个，刚才可能有很多，包括阮秘书长也讲了，就是说我们现在就是说碳硅气垫做出来了，但是我们可能就在封装这一块，可能还是沿用了原有的硅的一些封装的技术。就并没有把我们的碳纺硅的优势做更大的发挥。第二个就是我们要，就是刚才就是陈总也讲了，其实我们碳纺硅的应用它并不是简单的跟硅去拼低价格或者拼低端的应用，我们要高端，是吧？我们高压、高大电流，在这些方向那些推出的应用，是吧？包括像我们现在目前随着那个超快速的技术的技术的这个发展，是吧？1200伏的 SPD 和 MOSFET 的用量越来越大。是吧？包括是这个高压电网，包括像阮秘书长讲的我们的柔性电网，是吧？柔性电站，这些都需要这个高端。就是我们目前的不需要我们不紧盯着怎么样降成本，我们还要怎么样就是把我们东西做得更可靠，是吧？能够在更高端的领域有一些很好的应用，能够取得更高的溢价，这个才是我们的。我说，如果就是说，是吧？像现在目前就是可能这个兄弟是德国过来的，你看那个宝马、奔驰。是吧？那虽然卖那么贵，但还是有很多人去买，还有加价去买，对不对？就是它的那个品质， 我觉得应该还是更需要一个在我们的品质上面做一些文章，这样可能我们的整个产业发展才会更良性。当然，一味的降成本、压价格，显然你的可靠性差的话，或者是你是吧？那大街的话，可能这个并不利于行业的一个良性的发展。我觉得。
Very good opinion. So Huiling is talking about so we can, learn to use the pneumatic equipment, try to reduce the cost from the material to the equipment parts. And Dr. Wang said we can't just focus on how to reduce the cost because silicon carbide is suitable for the high power density application. So it's a high-end application. So maybe reduce the cost is not just the way to expand the market. We should care more for the quality instead of the cost. So what is your opinion, Chris?
I mean, going from 6-inch to 8-inch, the theory tells you that you have high utilization. Also from silicon, it was especially true for logic devices like CPUs, which have been like this size. If you go for discrete devices like MOSFETs, which are a little bit smaller in silicon carbide, then utilization is not the key role. I mean, as long as you have wafers that come at a decent cost, in theory 8-inch should be superior. If the wafers will be the limitation in terms of cost, because they are just much more expensive than the 6-inch ones, because the wafer manufacturers still have problems having the yield, especially also after wafer splitting. Usually right now silicon carbide wafers 8-inch are discussed with 500 microns, so you already see in terms of volume from the pool, you might not be at a good point. And just now Tanke explained that they shown the Asian Pacific silicon carbide related materials conference that they've shown at 351 afterwards. This is the right direction, but then wafer handling, and I'm sure that GPT knows well what it means if you have a strained wafer which already comes out of a strained pool and you look at it the wrong way, it just explodes. The yield in the end is of utmost importance to all the equipment, to all the device manufacturers, and they finally decide what process will be best for them in terms of economy.
Thank you, thank you.
补充这么一个问题呢，就说这个6寸往8寸切换，就即使这个8寸的衬底价格，从这个面积上、尺寸上来讲的话，可能做到6寸没有什么优势，但是单纯的从器件上来讲，这块已经可以降很多成本，是吧？所以说这个6寸往8寸切换，无论如何这个还是很重要。
Okay, so thinking about Dr. Wang, you mentioned about the quality. I mean, one of the important applications is, the silicon carbide products have already applied into the EV car sets for the Tesla. I mean, so for that automotive grade application, it needs, the reliability test requirements higher, and the client testing period is longer compared with the silicon device. So what are the main difficulties for silicon carbide material applied in the automotive grade areas from your views?
Okay, I'll answer first. To my view, I didn't see different for EV application and other application because actually our substrate specification almost the same. So I think it's actually depending on the manufacturer. Yeah.
For the EUR and the production way, they are the same for the industrial level and the automotive level?
Almost the same specification, especially only maybe dislocation density a little different. But I think almost the same level. Because we will not to grow, for example, FBD level in not on purpose. We will grow only one quality level products.
That is good news for a device maker. Basically the same.
Well, let's go a little bit more detail. And so I hope I don't bore everyone of you, but you know you have defects which are much more detrimental than others. So talking about defect densities as you know, some of basic plane and threading edge, threading screw, threading mix, it's maybe a little bit questionable. Huh? So you need to have a pool as less strained as possible to get a very low basic plane dislocation density. These defects are really killer ones when it comes to long-term stability under high bias. And as automotive now wants to see the 800 volts systems, you should have a safety margin for your devices which go at least up to 1700 volts, which is quite a fair amount of electrical field already in your drift layer with everything. And if you, with epitaxy, you can stop a few defects from the substrate, but others you can't. And then under bias, they can transform themselves into stacking faults. And this leads to bipolar degradation of the systems, and that in the end kills, or let's say, detrimentally affects the device. And that's why automotive guys now also work with a little bit of safety margin. They put more in than they would actually need. And here, this is the core of the whole story. You need to get rid of those. Whether you can do this by improvement of crystal growth, or for the substrates, or you find fancy ways in epitaxy to stop this. There are a few interesting approaches with hydrogen introduction, where you can actually stop a few defects in the drift layer. No matter what, in the second that you get rid of these things, the reliability goes up, and that's most probably the summary of what I want to say. Reliability is what automotive people want to see, because you don't want your car to stop somewhere.
这个就是，大家也说了，其实目前其实这个碳硅啊产业就虽然也很热，发展的好像也很好，现在投资者也很多，但其实目前其实我觉得碳硅最大的一个瓶颈就是还是在应用端，就是说用的不够。大家就是说都说很好，但用就是尤其用国产的并不是很多，包括现在随着这个疫情放开以后啊，很多汽车厂它也能够买到一些进口的器件，包括现在进口的器件也降价以后，其实对国内的应用的冲击还是蛮大的。就是据我所知，现在因为目前可能国内主要还是集中在那个低端的 SBD， 以前像那个Moderator， 包括像歌厂的配的，其实做的还并不是特别好，所以我就觉得就是说，包括人民讲在这里，我觉得应该跟国家呼吁一下，就是怎么样。就是扶持这个国产的一些器件的应用，是吧？就是以前我们普遍都是在生产的、制造的，但是我们怎么在应用的？就是你用国产的器件做的一些，是吧？这个汽车啊，或者是这个储能电站啊，这个我们国家给予的补贴，就是像以前光伏产业发展也是这个问题，因为当时因为由于欧美的双反，就是光伏行业遇到很大的困难，就连产品出不去，没有应用，没有应用就没有进步，没有发展。那怎么办？那就是国家当时也是在西部地区扶持了一些这个那个光伏下乡或者一些光伏电站的工程，先大批量的用我们的东西，先不断的验证、不断的改进，先整个产业在不断的良性的发展。
但是现在像有一些车厂，应该也有一些国产碳化硅芯片的引入。
据我所知，可能大家可能还是比较保守，不多。对，真正上车的可能除了咱们泰科天润。其他的还有我们的集团下面的事务所，其他的好像包括比亚迪的，它有一部分，它主要的还是进口的，它可能是进口国内封装啊。而且刚才我也提到了，就是可能国内在封装这方面还要做研究，就是说可能我们并没有把这个碳硅的效能发挥到最大。
Dr. Wang just said, how to face the difficulty of applying the silicon carbide polymers in EV. We can, launch some government policies to promote the SI domestic, SiC power device applied in the EV car like BYD, Geely, to promote the local collaboration together. He also mentioned so far for the package part for the silicon carbide module. For example, they are probably not the best way to present the silicon carbide characteristic. I think that is a Heraeus, your advantage, right?
mean, obviously also the back end is very important. So you have better thermal properties of silicon carbide. You can use it at a higher temperature, but nevertheless you will have to get rid, because you have a higher energy density, you have to get rid of the thermal losses. And yes, we are offering some advanced solutions with silver sintering, where you actually can make use of elemental silver to have the highest thermal conductivity that's available to get it somewhere. In the end, it's a holistic thing, but the whole issue of reliability is also definitely temperature dependent. The higher the temperature, the faster degradation you sometimes will see. Sometimes higher temperature is even good because you can heal out some defects, but nevertheless, get rid of them and you get a more reliable device.
贺律师他正好也是这个引烧结工艺，之前在碳化硅模块，他们本来也是有自己这个专门针对碳化硅这一块的服装材和技术。
I also feel that compared with foreign IDMs, our Chinese device makers, maybe the most important thing to improve is about the package. And this also was the issue related to the reliability. Of course, we from material side, we need to decrease the defect density all the time. Also, the epi growth technique is also very critical for the device yield and reliability. But package is very important. I think this is a field our domestic device makers have to improve.
Because the SiC device start from the high power application, so there is so much harsh environment compared with silicon. So reliability is very important. So this year is a good year. So finally the coronavirus ended, so we can travel, quite free, and you can travel here to join this, meeting in Hunan. But it also bad year because we can see the coronavirus and the global economy is going down. I don't know, right? Not much better than we thought. So what do you guys suggest when we facing this bad economy? So what do you suggest the local manager? How do they do to survive in this economy environment?
I tried at first. I mean, I'm that old. I have gray hair, so I'm a senior in the semiconductor industry, in some way. So I've seen many upturns and downturns in my life already. While this might be new to the silicon carbide community because it just went one direction all the time, you'll get over it. It will go down, it will come back, and it will come back stronger than it has been before. And silicon carbide is just another Lego piece of the semiconductor industry to become a $1 trillion industry. And we will see this by the end of the decade. So everything will grow stronger. Just be confident. And if there's a bad year, there's a bad year.
Okay, considering about the political situations between China and European and American countries, I think maybe our domestic companies will consider to make some fabs outside of China to face the worst situation if it will happen one day. But in my opinion, I didn't expect that the worst situation will happen, and I'm very looking forward to Mr. Xi Jinping's visit to the US very soon. So also I have very positive perspective for the future of the semiconductor industry.
我觉得无论这个碳化硅产业是一个很好的产业，是一个很好的赛道，但是呢，也是一个很长的赛道。 因为这个产业才刚刚开始，想象就是所以说，包括那个大家对这个碳汇的应用的认知啊，可能还是一个过程，就包括它的推广。所以我觉得，首先咱们作为一个中国的碳汇企业，首先第一个就是要坚持，是吧？这个行业就是说，你必须不断的坚持，活下去，以前才会等到那个敌人来的第一天。第二个就是我觉得要坚信，因为我觉得就是说，首先这个碳汇的主要市场在中国，因为它不管是电动汽车还是锂电器的主要市场都在中国。另外就是我们也有这个相对比较成熟的8寸的这个在碳硅基的一些积累的经验。因为我们目前就是产业非常完整，无论是从材料的层底啊、材料啊，包括我们的器件啊，包括我们的封装，包括我们的应用，包括我们的装备啊，都是产业是非常全线很难的。另外，我们作为中国目前来看，还是有在制造业方面还是有很大的优势，包括规模的优势、成本的优势，所以我们坚信这个明天一定会更好。在这里最后我也借用那个马云的一句话啊 ，Today is difficult, tomorrow is more difficult, but the day after tomorrow is beautiful, so we have to work hard in order to survive the long journey. Thank you.
That's a great end. So, is there anybody has some question for? You are free to ask.
Still any questions? Everybody's hungry. Okay, so thank you for all the